Good evening, Professor. We are Team 24, and today we will be presenting our project titled Predicting Construction Accident Severity Using Machine Learning Models. And our team includes myself, Aniket, CNST, Srivardhan, Deepak. And coming to the contents of the presentation, we will start with the introduction and then problem overview. And then we will go through data pre-processing, data exploration methodology, and then results and analysis, key findings, and the future directions of our project. Next, coming to the introduction, we will take a quick overview. Construction is one of the most dangerous industries worldwide. Even with the safety training and strict rules, accidents still happen, and not all of them are the same. Some are minor, but others lead to the serious injury and even death. Predicting the severities of an accident is very difficult because many factors like location, weather, equipment, worker experience, and more can come into play. In this project, we aim to use machine learning models to help predict how serious a construction accident might be, which can support better safety planning and faster response. Uh, Next, and the problem overview is construction environments are complex and full of dangers. Despite using protective gear, safety trainings, and other measures, accidents continue to occur. The challenge is not just preventing accidents, but understanding how severe they could be when they do happen. The different factors include like the type of task, number of workers, environmental conditions, and more, making it hard to predict the accident outcomes using traditional methods. So we need a smarter data driven approach to help improve the predictions and reduce risk. And coming to the existing research that is already in the market, which is several past studies have explored accident predictions in construction. For example, some have used the statistical models while others applied machine learning techniques like decision trees and support vector machines. These studies have shown that the machine learning can improve prediction accuracy compared to the manual or rule based methods. However, many of them focus on the binary classification or lack of real time prediction. Our work builds on this research and aims to use the advanced models like random forest and XGBoost to classify the severity level of the accident more accurately and efficiently. Now, my friend Avinash will continue with the rest of the PPT.
In this project, we have outlined for 4 key goals. First one is characterize. This helps us in better understanding the nature and severity of the different incidents. And second goal is deliver. Our goal is to deliver actionable insights for managers and policymakers. These insights can help them to make informed decision and avoid severe incidents in the future. And the third goal is strengthen. By providing strong and actionable data, we want to strengthen the safety planning and improve overall safety with strategies. Coming to the fourth one, forecast. Finally, we seek the forecast potential risks and offer tailored safety. Coming to the next slide. Uh, in this project, we have worked with the dataset consisting of 4,847 records and 25 attributes. And these attributes cover a wide range of information related to accidents. We focused on important features such as event types and high fall height and human behavior, enrollment, task and project cost and injury type. To prepare this data for analysis, we have followed these pre-processing steps, handling the missing data by using mean or mode imputation methods, and enhanced categorized uh, variables by using the techniques like one hot encoding and frequency encoding and normalized numerical data. Coming to the second slide, next slide. Uh, EDA, exploratory data analysis. In this exploratory data analysis, we had focused on understanding the structure and relationships within the data. Categorical variables, we had explored the variables like event types, human behavior, and environment and task categories to see how it affects the outcomes. And coming to the next one, categorical variables, we have analyzed and continuous data such as fall height and project cost to find the patterns and designs. And coming to the next one, correlations, we had checked the correlations between the numerical attributes to understand strongly that they are related to each other. Coming to the next one, target analysis, we have examined how the severity of accident is distributed across the different variables, helping us to identify the main factors influencing the accident outcomes. Next, my friend Deepak will continue.
Next slide. This slide presents the frequency of top categorical features. Others dominates many categories, suggesting data labeling issues. It helps identify which categories are more frequent and potentially significant for predicting accident severity. Next slide. In this slide, we can examine the spread of numerical variables like age and work hours. These histograms help identify outliers, skewness, and data trends. Understanding distribution supports decision on pre-processing and feature selection for modeling. Next slide. This heat map shows the relationship among numerical features. Strong correlation help detect redundancies and influence future selection. It also ensures the model is not biased by overly similar variables, enhancing predictive performance. Can you go for a next slide? Here we analyze how accident severity relates to numeric features such as age or hours we work. These comparisons highlights influential variables and guide the selection of impactful features for model training. On the next slide, here it shows how severity varies across categorical factors like task assignment or event type. Recognizing these patterns helps identify key risk categories and improves the model's ability to classify accidents outcomes. From here, my teammate will continue.
Well, coming to the proposed methodology, the methodology includes we'll be utilizing several machine learning models to predict the severity of the construction accidents. These models include logistic regression, random forest, SVM, KNN, XGBoost, CATBoost, etc. And also we'll be evaluating the performance of each model using the metrics, accuracy, precision, recall, and F1 score. Including this, we in this methodology section, the hyperparameters are optimized for each model, and also the results are visually provided through ROC and PR curves. Next, and you can see we can have a clear look of the overall accuracy of each model, where logistic regression is regression has an accuracy of 89%, random forest of 90, and decision tree of 88. And also the key features in this are logistic regression has task type and also environmental aspects. It is good. It is simple and good for benchmarking, but not. It is not applicable for complex relationship. Whereas random forest handles mixed data and avoids overfitting, but it may require tuning for a better performance. Whereas decision trees is an interpretable model, but it may or face overfitting issues. Next. Well, coming to next models, we have SVM, which is with an accuracy of 89%. It is environmental. It has effective for linear relationships, but has sensitive to parameter selection. And coming to KNN, which has the least accuracy, it is simple, but only for applicable for smaller data sets. While coming to the larger data sets, it won't be applicable, and it may have the presence of outliers in it. And next we have Navy bias of accuracy 84%. The key features of the job description, people related issues, physical characteristics. The advantages, it will be applicable for large data sets, but it assumes independency between the features. Like, while coming to these are the most new models which are XGBoost with an accuracy of 92%. The XGBoost handles complex data and has a high efficiency, but it is computationally very intensive. And coming to light gradient boosting, it has an accuracy of 92%, and the key features are fast training at good, and it is good for high dimensional data, but it may be having overfitting issues if not tuned properly. And finally, the CATBoost with an accuracy of 92%. It can handle categorical data effectively, but it may require substantial computational resources when in some cases. And next we do have the evaluation metrics. Other than accuracy, we have precision, recall, F1 score, etc. F1 score, and we can have a clear look of XGBoost and light GBM having the high accuracy, precision, recall, and F1 score compared to each and every algorithm. That gives the best suitable algorithm for predicting the accident severity in construction sites. Next. And finally, we have a visual representation of our results, where we do have ROC and PR curves. Through this, we can have a clear look of the overall accuracy and the model accuracy and model AUC of the each and every model. From here, Aniket will be continuing. Thank you.
Well, Professor, going forward, we look at the model performance summary. We can see that the top performers are XGBoost, Light GBM, and CAT Boost. They have 92% accuracy amongst themselves. The mid-level algorithms are random forest and logistic regression, which are in the ballpark of 89 to 90%, while the lowest being KNN at 83%. Ensemble models excel at identifying complex patterns is the conclusion we draw from it. The applications are, we can improve construction safety by forecasting accident severity, focus safety actions on high-risk activities, and tailor workers to mitigate specific risks, as well as streamline inspections based on predicted hazards, as well as inform better safety policies and resources use. Uh, on the whole, we can conclude that machine learning models can reliably classify accident outcomes and feature selection and balancing improved model reliability. Visual tools help interpret the performance better, as well as models can support real-time monitoring and smart city safety efforts. We have a few ideas which we want to implement in the future, them being integrating live data, time, weather, traffic, tech, and environment, as well as refining algorithms to handle better imbalanced data. We want to implement continuous alerts using the inputs, which can be really helpful to the construction workers, as well as we want to link to smart city systems to provide safety on the whole to the city. It can act as a proactive safety management tool. Well, these are some of the references which we have gone through to while working on the project. These are one of the most esteemed journals which we have looked up and which we have taken inspiration as well as ideas from. This will be attached in the PowerPoint presentation as well as all the documents. And finally, I want to conclude we want to conclude the project by showing a demo of how the model works. Going to the model, I've already loaded the data set so that I can show how the model works. I'll be running the code with the accident report CSV file, which is our data set, so that I can show the live working of the models. While we go through it, we can see that the code is quite self-explanatory, wherein we are installing all the required modules. Now we are importing necessary libraries such as NumPy and Pandas, as they are quite important in any machine learning algorithm. Here we are even reading the data set, and we can see that few of the data set it is displayed so that we can get a clear idea that all the information is intact and we haven't lost anything while reading the file. Going ahead, we have even checked the information of data. All the data set types. What are the data set types, as well as whether they have constraints such as not null or null. Going ahead, we can even find out the number of duplicate rows so that data redundancies can be eliminated in the first place itself. We have checked out some basic statistics of the data so that it will give us a clear insight into the data what we are working with. Finally, while going into exploratory data analysis, we can go through various graphs such as the correlation matrix, as well as various dot points between building storages and the degree of injuries. This graph, like we have discussed in the PowerPoint presentation, it is a count plot for categorical features against the target variable. And this is the histogram for all the numerical columns which we have included in our data. And finally, we have also visualized a pair plot to show the relationship between all the variables which we have taken up in the data set. This is another uh, this is another box plot wherein we are showing us we are showing the number of columns as well as number of features relationship. And these are some of the other graphs, such as a relationship between degree of injury and number of count. Like we can call it as a distribution of degree of injury. Few more graphs, such as the box plot as well as another pair plot. Going ahead, we can see various. Here we are speaking about feature importance, such as what are the top 7 categories of event type and the environmental factor, top 7 categories of human factor, and distribution of task against. Looking at this graph, talks us through about distribution of project cost as well as the number of injuries. Another correlation map to show the correlation between the numerical features. The first one was for categorical features. Yes, we have handled missing data types as well as any data redundancies. We can see the feature importance for random forest, wherein event here is the feature with the most importance with regards to a random forest algorithm. And yeah, we can now the models are working. We can see that the precision recall F1 score, the results of logistic regression, the results of a random forest classifier, a decision tree classifier, the results for the SVM classifier, the results for KNN classifier. Here we can easily make out that this is the least of all the results which we have gotten till now. And the naive-based classifier is used for bigger data sets. And now coming to the ensemble models, we can see the results are quite high when compared to the other models, which drives home the fact that ensemble models are better prepared to handle such complex and real-life data. Bridge classifier, is another ensemble model along with a neural network classifier. Looking at all the classifiers, we can see that their precision is higher amongst the other basic models. This is the code for the ROC and AUC curve, as they are really important in visualizing our data and how our models are performed against them. So going ahead, we want to include this project with various other real life data, and we want to thank you, sir, for giving us the opportunity to uh, go into real life situations and build a project about it.